After watching what just happened, you're probably thinking, whoa, how cool! Well, let's do some physics to see if this jump is plausible or not. We want to first start out by seeing what variables are known and unknown. The variables that we know are that v1 equals 0 meters per second because the man starts at rest, the v2 is unknown, the acceleration is 7.15 meters per second squared, which we researched, and the time it took the man to jump was approximately 6.86 seconds, which was timed from the video, and we also don't know the distance. We're first going to solve for distance by using the third kinematic equation, which is d equals v1t plus 1/2 at squared. We want to plug in the information that we have, which will give us a final answer of 168.2 meters. For our next step, we want to find the velocity at the end of the bridge. The values that we know are that v1 equals 0 meters per second, the v2 is still unknown, the acceleration is 7.15 meters per second squared, and our time is now 11.34 seconds because we added on the time it takes to reach the end of the bridge, and our distance is now 220.25 meters because we had to add half a bridge length on average, which we researched to be 52.25 meters. We now want to sub this into the fourth kinematic equation to solve for v2. Our original equation is d equals v2t minus 1/2 at squared, which can be rearranged to solve for v2. We want to plug in all of our known values and solve. We will get a velocity of 60 kilometers an hour, which will equal out to be 16.7 meters per second. So our third step is to find the angle of the bridge. We found this by using a protractor on the screen and then subtracting that number from 90 degrees to give us the angle at which the man jumped from. This angle turned out to be 62 degrees. So after, we now want to solve for the bridge gap size. So when we want to solve for the bridge gap size, we have to plug this into the equation cos equals adjacent over hypotenuse. Our hypotenuse is going to be the half length of the bridge, and the adjacent will turn out to be 24.5 meters. After we found that, our fifth step is to find the gap of the bridge. We will find this by subtracting the adjacent length twice from the average length of the bridge, which will give us a gap size to be 55.5 meters. Our final step is to find the horizontal distance at which the man must have traveled. For this, we're going to use the equation d equals vt. So first we must solve for the velocity, which we will get an answer of 7.8 meters per second. We then want to plug the v into the equation and solve. The time that we plugged into the equation would have been the amount of time that the man was over the bridge. We get a horizontal distance to be 29.6 meters. The horizontal distance traveled by this man is much shorter than the distance that he would have needed to travel in order to make the jump possible. If we take a quick look back at our video, we can see that it says in the corner, "Do not attempt." This is because the jump is not possible. Our results are that the man realistically wouldn't have been able to make the jump due to him jumping a much shorter distance than that would have been needed for him to reach the other side. We know this because of physics.
For the second part, we will be analyzing whether the man would be able to continue running after the jump without breaking his legs. The known variables are the final velocity was 16.7 meters per second, which we got from previous calculations. The distance was 168.2 meters, which was also already calculated, and the mass was 90 kilograms, which is the average mass of a man. First, we solved for kinetic energy using 1 over 2 mv squared, which gave us 12,550.05 joules. Then, using kinetic energy, we found force by rearranging energy equals force times distance. This gave us 74.6 newtons. In conclusion, yes, his legs would have been able to withstand the force because the human femur can withstand 4,000 newtons before breaking.